Hello, esteemed evaluators. I'm Sanjay from Team Tiki Hackers.
We are here to address one of the major problems in the world right now, that is diabetes. Diabetes is not just a health issue, it's a global epidemic that affects millions of lives and has far-reaching social and economic implications. Diabetes is on the rise worldwide, with more than 400 million people currently living with this condition. Every year, millions are diagnosed and many more remain undiagnosed, putting their health at risk. So, diabetes cannot be cured permanently, but it can be controlled with lifestyle activities. But a diabetes patient has to regularly measure their blood glucose. Research suggests that a diabetes patient has to at least measure blood glucose 10 times per day. So, I would like to address issue which happened in my home. My grandmother and my father has diabetes. Every time if they need to measure the blood glucose level, they need to go to the nearby hospital to measure. So we thought of buying a blood glucometer in our home. And on researching, the glucometer cost around 1,500 rupees. It's a huge amount for normal people to buy. It does not stop there. It every time we need to buy a new strip to ingest and take the blood glucose. So it also costs huge. And it is a invasive method because every time we need to poke our fingers to take blood, it pains, right? So we thought of addressing this problem. That's why we came up with the idea called visionary glucometer. So our solution is to predict the blood glucose level through the iris image. So this cutting edge project aims to transform the landscape of diabetes management by providing a non-invasive approach to glucose monitoring through iris image using deep cutting edge technology like deep learning. So my friend Naveen Kumar will explain the evidence behind our solution.
The research work behind this cutting-edge technology were conducted with the help of these three fellow papers: Dr. Aravind MBBS MS, Haris Prabhakar, Doctor of Pharmacy, and the Satyabharati Ravichandran, Immunology. So basically, we targeted this anterior chamber, which is in front of the iris. This anterior chamber plays a major role in the iris structural changes. Actually, the anterior chamber, which contains a special fluid known as aqueous humor. This aqueous humor gets directly correlated with the blood glucose level. This graph shows that there is a potential correlation between our blood concentration and then eye data of an aqueous humor. So based upon this relation, we come up with another relation between aqueous humor and then intraocular pressure. This intraocular pressure is a special pressure produced in our eye. So whenever the increase or decrease in the aqueous humor concentration, the intraocular pressure, which is also increase or gets decreases, these are gets directly correlated. So finally we come into a conclusion and we found that our blood glucose level concentration is directly correlated with the aqueous humor, which is of anterior chamber, and this aqueous humor concentration is directly correlated with the intraocular pressure. So this intraocular pressure will produce a structural changes, that is contraction or dilation of these parts of iris, so namely the crypts, pupillary zone, ciliary zone, radial furrows, contraction furrows, and the pupil region. So all these parts of iris gets contract or dilate based upon the intraocular pressure produced inside our eye. So based upon this, we come into a conclusion of innovative idea. This is using the image recognition technology, we can find the structural changes of this iris. So based upon these structural changes, we can measure the blood glucose level of our body. So here we eradicate the pain point of taking the blood using the pins of a fingertips and also reduce the cost of using the strips. So everything we reduced over here. This is a more effective idea rather than using the glucometer. Thank you.
Let's move on to model building part. To develop a model, we have collected a data set from two sources, primary and secondary sources. These data include eye image along with this blood glucose level. So from this eye image, we did some pre-processing steps to capture the iris structure, and which I will show in later part. So in the model building part, we have utilized a CNN-based architecture to accurately predict the blood glucose level along with the iris structures such as ridge crypts and furrows. And with this structure, we are able to predict the blood glucose level. And our model accuracy is around 80%, and its loss is less than 50%, and it makes less false prediction compared to other. And we are trying to improve our model with other by increasing our data set size. So let's move on to the pre-processing steps we have done. So we have replaced a CAN-based architecture to separate the iris structure, and you can see that this is a high quality image. From this you can see the changes in the crypts, furrows and ridges, and with this we are able to predict the blood glucose level. These are the pre-processing steps done to predict the blood glucose
See the
level.
working demo of our application. You can either upload the image from the gallery or by taking the real images. For this, we have used the macro lens to get the clear view of the eye, and you can crop this image to get the required image alone. And from this, you can upload this image in the backend. In the backend, our AI inference engine will examine this eye structure and do the pre-processing step and able to get some inference and produce the output. So the output is 92.82. So actual value of the patient is 94. So only a 2 difference you can able to rectify this. Let's explore the other feature. Other feature is the food recommendation feature. This provides the food recommendation according to the blood glucose you have. So this provides the food recommendation for morning, lunch, and dinner. It provides a well-formed diet with starch, foods, and vegetables, and even juices. It also provides a snacks which helps to solve your cravings at the moment. And let's explore the other feature. The other feature is a Nutri Glucose Check. So this is the innovative feature which we added in our application at the last moment, where you can simply upload the fridge picture or any other ingredient picture which you have in home right now, so that our AI object detection model will able to detect the ingredients which we have in your home at the moment. And with the help of the GPT, we are providing a dish recipe according to the ingredients you have in your home and the blood glucose you have currently right now. This feature helps the old age people to reduce their decision making and helps them to solve their problems at the moment. Thank you.